Welcome everybody back to our effect cluster development sessions. So I think the last time we met, we were still doing like a lot of design work on cluster, and since then, I've started to try to implement some of the things that we talked about. And while I was doing that, it became increasingly clear that it was going to be more challenging to shoehorn what we were chatting about into the existing cluster library than to potentially just try rewriting from scratch and borrowing a lot of the ideas from our previous implementation along the way. So that's basically what I did. I started this cluster rewrite branch, which I've started kind of like hacking on. But basically, I moved everything from the old cluster into this cluster old folder, and we have the existing cluster folder here. And um, if we take a look at source, I've already implemented a couple of different things which we can talk about. But yeah, I think that it would maybe be a good place to start to talk about some of the things that I've already started implementing here. So,
Max, just one small thing. Given that you don't use the mouse anyway, get it out of the screen.
is it in the middle of the screen? It is. Okay, sorry. I don't see it when it, so thank you. Um,
I mean, you
all right.
use the text editor with your keyboard, so there's
I,
advantages that you can.
I'm just saying, I don't see it on my screen. My mouse goes away, but if it still shows up in the stream, definitely let me know.
I will.
Um, Anyways, so one of the first things I did was in the previous cluster implementation, like shard IDs, entity IDs, message IDs, all of these were just kind of raw, like string and number types. So the first thing I did was I created branded types for them to see how it felt. I'm not 100% sure that I'll stick with this, but I thought it would be a good place to start to have branded types by default for now. Just again to make things a little bit more explicit. So I have this shard ID type, which is an integer that we branded, and then not currently using this particular schema down here.
They use the class variants.
Yes, how do I brand a class variant?
I think you can just do like export class shard ID extends schema.int.pipe. If I recall correctly, Julio made every schema
Oops,
classable. Uh,
you're
it's not going
probably
to
right.
be the.
Class shard ID. Let's try extends schema dot
And given that we are rewriting everything, who cares?
schema dot int
It should be .int.pipe.
um, pipe schema dot brand. Oops. Shard ID. That's cool. Julio doing all of these very, very cool things with schema.
And
Certain.
we should then access the type like with shard ID dot type of shard ID dot type.
Do we need that since the class is already a type?
Yes, because this is a number.
Clear.
Only the.
Shard ID equals type of shard ID dot type.
Yeah, well, we can't do that though. We can do export namespace shard ID, export declare namespace shard ID, and have a
Mhm.
type.
Oops. Export type 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 of shard ID dot type.
Yeah, I think that's it. Even though it's not very important because I mean those will be unaliased anyway.
Yeah. Right now I'm not using this one here, but we might. Actually, am I using it? I don't remember. But yeah, this is already very good. Cool. Let's give the same treatment then to. So I did the same thing with entity ID.
I mean,
So
I think we should like we should have a think in terms of accessing that type. Is it too painful to do type of and just access it locally? Because when we decode and encode, it's not gonna use the alias anyway.
true.
So even though we define the type, it's not gonna be used. It by default uses the unaliased thing, so we need then to type it manually. If we need to type everything manually, then I think your style is better because at least you have type and schema using the same name,
Yeah.
and you don't get that with the class.
I think it'll become clear from usage. Like, I think we need to get to the point where we can like write up a small example, um, and then it'll become a little bit clearer with usage. I feel like
Then I think the our best option would be to revert what you've done in the shard ID to your initial thing, and then with usage we see.
all right, let's do that then. Do, do, do. All right. So we have shard ID. It's just a branded integer. We also have entity ID, which is a branded non-empty trimmed string. Uh, and then we also have a message ID, which is also a branded non-empty string. Um, and then entity type is also a branded type, because in our, if folks recall, um, we can actually just look at it first. The first thing that we might be interested in is how pods in the cluster are addressed. So we have this pod address type here that allows us to address pods by their host and port. And then similarly, the next logical question is like, okay, we can address pods, but how do we actually address entities on those pods? And for that, we have an entity address, which contains the shard ID, the entity ID, and the entity type that we're trying to address. Because if we think back to the previous stream where we like sketched out what a single pod actually looks like, on a given pod you might have multiple shards, and in those shards you may have entities of the same type, but that have different IDs. So you have user with ID 1, 2, maybe there's like a to-do entity, whatever. So the idea here is we can now address like entities using their shard ID, the entity ID, and the entity type. And I actually like putting the entity type first because it's the less specific. Um, so then, so we talked about pod address, entity address. What else did I do? I re-added our entity type from the existing cluster, which I renamed just like a few things, but essentially an entity within our cluster can be either just a standard entity, which exists in a single location on a pod, or it can be, we had in the previous iteration of cluster, we called this um, a entity. It was, this data type was called like a recipient type, and it was either a recipient type could be an entity or it could be a topic. In the previous cluster implementation, I changed the name to like entity and just made it a standard entity versus a clustered entity. Um, and clustered entities you can broadcast to, whereas standard entities you just message directly. So the naming is like debatable, but I thought entity was a better name than recipient type from like a usage perspective, because when you actually like declare an entity and its protocol, you're going to do something like you can actually look in the cluster node code example. Um, when you actually declare an entity, instead of doing this like recipient type dot make entity type or recipient type dot make topic type, you would now do like, entity dot standard. You would say like export const counter entity equals new entity dot standard. The type would be counter, and the schema would be counter message. So just basically trying to like rename things to make them a little, I don't know.
What's the point of a clustered entity? I'm
I
not
don't
sure I
know.
follow.
I don't know yet. It's in the previous implementation. It's like it was called a topic, and that's the same like parlance that Shardcake uses. I don't know what the purpose of it is yet, honestly. But I think the idea is it's something that you can broadcast to. Like it's an entity that lives on multiple pods that you can broadcast to. Um, but I honestly don't know. Even from looking at Shardcake, their docs don't make it clear. I left it there for now, but it's very possible that I will take it out because it might not make sense.
I was about to say, if you're rewriting from scratch, it might be best to just remove things that we don't understand and add them when they make sense.
Um, yeah, I mean, it's very possible I'll end up taking this out because at the moment it doesn't make sense to me. The what I understood is that a topic type, or what we're calling a clustered entity here, is an entity that could live on multiple pods that you can broadcast to. Because if we look at the previous cluster implementation, um, when you use sharding to create either a messenger that is addressing a single entity, but you can also use sharding to create a broadcaster.
I understand it from the point of communication, not
Yeah,
from the point of the entity itself.
yeah, I
Because
agree. I think that it's not clear to me yet, so
like
it's very
having a messenger that can broadcast to all of the entities of the same type makes sense. But when I create an entity, it has a single ID. So it has an identifier, it cannot live in multiple places, the same one. So I think there's a there's a mixture of concepts. Like in Shardcake, it probably refers to the messenger, not to the entity type. So it's probably not an entity that can live in multiple places. It's just a messenger that can target all the entities of the same type.
the in Shardcake, there are two recipient types. There's an entity type and a topic type, and they also have the concept of a messenger, where like you have either a messenger or a broadcaster. A messenger addresses like an entity type. A broadcaster addresses a topic type.
Yeah,
Um,
but the topic type targets multiple entities. It's not
Correct.
a different type of entity. Like
It
you,
is not.
an
Yes.
entity is linked to a behavior.
Yes.
So
So
it's very confusing to have a clustered entity versus a standard entity. I don't.
yeah, it's not clear to me either, and so I'll probably remove it. But I was just moving stuff over for now. So I left that as is. The other thing I moved over pretty much as is was the message state type. But we had discussed, I think this was offline, that we might want an additional message state of like received here, for decoding purposes when it comes out of the database. But again, I haven't had to use this yet, so I'm not exactly sure if we'll need it. But what I do want to talk about now, which I think is like a useful thing for us to discuss, first, is what I've been working on for mailbox storage. So we talked last time, a little bit about how when a pod receives a message, that message is wrapped up into an envelope which contains other metadata about the entity that we're addressing, um, on that particular pod. Um, and we had talked about uh, the like how we wanted this to work. Basically, the idea that we had was that the mailbox storage would be when a pod receives a message, the first thing would try to do is persist that message into mailbox storage. If the message gets persisted successfully, then we know that that message is not a duplicate; it's a new message, and the the pod can then forward that message along to the entity that's being addressed by that envelope. Um, so maybe even better, first thing to take a look at would be this envelope type because I'm not satisfied with this type. I wasn't satisfied with it in the previous iteration that we had because I think it was difficult to work with. I still think it can be improved, so maybe let's take a look at this. Um, so let's take a look at this and see if we can make this a little better. So right now, the envelope, as I mentioned, is a wrapper that contains all the information we need to address an entity, and then also contains information about the message that we're sending, um, the message ID and the body of that message, which is just like whatever we're actually sending. Um, but working with envelope at the moment is difficult because how do we know when a pod receives an envelope? We know how to address the entity that it should go to, but then like decoding the message becomes somewhat annoying. And so we can talk a little bit about that. But first, on initial glance, does this envelope type look like what you had envisioned when we had previously spoken about it? Basically, having the address for the entity itself, and then having the information about the message that we need to be able to address it.
Yeah, I think so. I don't quite get why this has to be a schema. It has to be serializable, but
Well, we had said the envelope was the thing going over the wire, right? Between pods. Like the envelope was basically like the packet of communication that's going to be serialized to go over the wire between pods, and then that's kind of the first step of like getting the message out is like deserializing the envelope so that we get that information.
yeah, I kind of meant the runtime representation, not really the thing that travels. Point is, we have a serialized message inside here, so if we then serialize the envelope too, we have twice serialization, which I'm not sure it
This
makes sense.
right, and that actually was still a problem with the previous envelope implementation. We actually had a triple serialization problem there because we had the runtime representation that had the type information. Oh, hey, Mattia.
We
We
have,
had
yeah, Mattia's on.
he's in the chat. Yeah, the envelope is a serialized packet. It could be omitted and not be a schema, but then would require. Yeah, so I'm still not convinced that this is the right like abstraction because it's difficult to work with. I think we need something that represents the message that travels over the wire and gets persisted into the mailbox storage. And then we need a way to take, like, the idea being that, like, pod receives a it attempts to put that message into the mailbox storage, right? If it successfully does it, then we should get a message back from mailbox storage, right? We should get, like, metadata about that message. So like in this implementation here,
Like sequence number and all
right,
stuff. Yeah.
we get here what I've called like a mailbox storage dot entry. It's like basically represents what we have in the table. Um, but the message body here is still like something that we don't know. It's like an unknown structure, and technically the entry it's a string, but I left it as unknown for now. Um, so this is kind of like the first step. The pod receives this envelope. We attempt to put it into mailbox storage. This should not be like this. It should really be like some error type, but for now I left it as an option. And then if we successfully get an entry back, we know that mailbox storage persisted that message, which means the message was not seen before, which means that we can then take that message and forward it on to the queue of the entity, like to the actual mailbox of the entity that we need. So what I'd really like to talk about like in granular terms now is like how do we represent all these types? Because envelope is still difficult to work with. I think we can find a better way. And then we need to talk about like, okay, we get an envelope and we need to serialize it. into, or we get an envelope and we need to persist the message, which I already have some code we can look at, like for mailbox storage. And then, assuming we successfully persist it and then we need to forward it onto the entity, how can we basically give the entity the, ideally, like the message itself, like, or I mean, because the entity is the thing that knows how to deserialize the message, right? Like you might have multiple entities on that pod, right? The entity is the only thing that has the protocol for that message, that knows how to like actually take it and decode it. The pod doesn't know how to do that, the entity does. So we have to talk about that piece as well. But maybe we can start with, we receive a message over the wire. What does that look like? Like, is envelope the right abstraction or not? And then we put that into mailbox storage. I think that's like a good place to start, maybe.
I mean, envelope is just a pair of two things. So either we have a type for that, or we just have two things: address and message. I
Right.
don't quite see the
Well, what makes more sense? Packaging it up, making it a serializable thing, or
either. I would start by saying, why do you think it's hard to work with that? What
it's,
problem does it generate?
well, the problem really happens after we've tried to persist it. Like right now, working with envelope is fine up until the point we get an entry back from mailbox storage,
But
and
when we
then
get an entry back from mailbox storage, the envelope is gone. There's no longer an envelope.
true. Um,
So,
so maybe, okay, let's take a look at mailbox storage, the actual code. So
like, the envelope is the input to that procedure, not the output.
right. So I've got a some code here to actually create the mailbox storage. I think having multiple implementations would be useful, like especially if you're trying to test. Like having a memory implementation would be really useful if you have a single pod and you just want to test. Having memory implementations of all of these would be good.
Yeah, an
So
index
for,
DB one in the browser, and yeah.
exactly. So make SQL one creates a is a constructor for mailbox storage that relies on a SQL client, basically. And I wrote this in such a way that hopefully it's dialect. I do a good enough job with the dialect to handle. I know that this works in MySQL because I've tested it against a live database, but I don't know about other databases. We definitely need like tests, obviously. But this, so the first thing we
Why
do is,
are we using on dialect?
because MySQL. Okay, let me show you the dialect independent one, and then I'll show you why we need on dialect. Um, when we insert into the mailbox table, we're doing an insert select. We've talked about this query before, but we're basically doing an insert select so that we can filter out duplicate messages, right? And we can also use coalesce to increment the message sequence number if it's there. Otherwise, default it to 0, right? Um, the problem that we're solving with on dialect is basically returning the information from the query. So using a returning to get the information back for the mailbox entry, which is not supported in MySQL. Um, so in the MySQL, everything else, every other dialect falls into this or else category because I don't actually know about MySQL Server or SQL Server, but I know Postgres and SQLite, the other two dialects that we support with our SQL clients, do support returning. So for now, I had to write a separate implementation for MySQL where we do the insert first, and I added this new raw helper to all of our SQL, the statement type in SQL, uh, in effect SQL. So all the SQL clients support this like raw type helper on statements, which allows you to get, in the previous implementation when you'd run it, or in the current implementation when you run a statement, if it does a little bit of filtering to get the rows back. So if you're not returning an array, you essentially get an empty set of rows. But with MySQL 2, when you do an insert statement, you get metadata back about what actually happened during that insert, since it doesn't actually support returning, but it does give you metadata back. And that metadata is called a result set header. One of the things in that result set header is the number of affected rows by the insert statement. So using raw, you actually get the raw response back from that SQL client. So raw is like an unknown, has an unknown type here because you don't know what you're getting back. It's literally the raw result that happens when you actually run that SQL client, whether it's MySQL 2 or a SQLite or whatever, against the database. But what's useful about this is now I can actually look at the number of affected rows and decide whether or not I can run my select statement. So I try to run my insert query here to do the insert of the message into the database. If the number of affected rows is greater than 0, then I actually try to select it. Otherwise, I give back an empty array.
I'm
Um,
wondering if we can somehow forward the two queries at once and make the second conditional, because this way we have a full network round trip to insert a message, which would be a lot more slow.
I mean, we could probably do this with a I'm gonna say these words and then I'm gonna regret them. We could do this with like a stored procedure in MySQL, but even the words coming out of my mouth don't feel right. So let's not do that. I don't know how we would do this without doing two network round trips with MySQL.
Or with a storage procedure.
No, 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 no. We're not doing that. That's gross.
No, because I mean, this has the first network round trip to insert, then it reads the response and has a second network round trip to fetch the thing. That's two times back and forth from the network. That's pretty intensive for a single message.
Yeah, I mean it is. Uh, that's the problem with. I mean, either we do something dirty like a stored procedure, or we make it known in the documentation that, like, you might not have as good performance with MySQL than you would with like Postgres or SQLite or something like that.
Well, optimizing for MySQL sort of makes sense because if we target clustered environments, uh, Postgres is really not great at clustering in the sense that every connection to Postgres is extremely expensive, and MySQL is much cheaper in that. It's a terrible database otherwise, but uh, yeah, I mean, Postgres is the real deal when talking about SQL. But the issue is scaling Postgres, where you then need like bouncers on top that do connection pooling, and it's much more more complex.
Yeah,
If you use MySQL, then you have even stuff like Vitess, which does insane sharding plus scalability of MySQL systems, which is what, for example, is used behind the scenes in PlanetScale and those serverless providers for MySQL. So I do see, like, if we think a normal target to deploy this beast, you would have like a database coming from PlanetScale, and you would have some persistent processes coming from, for example, Fly.io, or in a more long-term future, you might have everything inside an effectful cloud if it ever exists. But still, you need a database that can support
yeah,
a growing amount of connections, and usually you get easily a MySQL. Now you can also get a Postgres with Neon with other stuff, but the scalability of that is more limited. So my point being, trying to optimize for Postgres, but we should not ignore MySQL. It's equally important.
oh for
Probably I
sure.
would start with a Postgres at the beginning just because it's a better database. But at some point, in my previous life, I had to actually move from Postgres to a MySQL due to performance at scale. Like we
Yeah, I
we
mean
were hitting 1 terabyte of memory. That was a bit
we
too much.
I mean The other thing, like, I mean, this is getting a little bit out of scope of like this particular discussion. Maybe not, but like the other thing I had been thinking about is migrations and um, like if we want to manage a stored procedure for MySQL specifically, I think it would be possible. I can look into it as like an option here, but for migrations, I was actually thinking it would be a really nice user experience if we did something like I don't know. Have you ever used the Alembic? Like it's in Python,
In
but
Python, yeah, of course.
yeah, I really I mean, I think that the experience there is nice. So um, for things that use Alembic under the hood, for example, like if anybody's ever deployed Airflow into like an environment or like trying to think of like another one. Uh, there are plenty of things that use Alembic under the hood, but what's nice is that we could probably do something similar with Effect, where migrations are not necessarily persisted to the file system with the SQL client, but like we have like a table that we write to our SQL database that allows us to um, basically cleanly migrate between like in Alembic you'd have like a version number for the schema that you're applying, and you can up and downgrade the schemas with that. So like the reason I'm bringing this up is because we could potentially support a stored procedure if we manage like migrations that way. Um,
Well, I mean, I understand from a user perspective if you want to use the database for anything else, but we are only requiring a single table in that database, which is the mailbox table. Per
yes and no, because technically we also have other cluster storage. You don't. I kept them separate because like you may want SQL for your mailbox storage, and maybe you want like Redis for your shard assignments and things like that. But like in
possible they
theory,
are two different things, though.
right? But that's what I'm saying. Like I kept them separate for now, but in theory, like you could use the same database for your regular storage, which is where you would do things like your shard assignments and like your pod assignments, things like that.
Yeah,
Um,
but I do think the cluster environment itself could manage the database in this
yeah,
case.
yeah.
So instead of the user running the migration, which would be what you do with Alembic, you'd have the cluster
Well, no,
that manage the
I was
structure.
thinking I was thinking more about how like software like Airflow uses Alembic, where you don't actually run the migrations.
Ah, okay, got it.
You have the ability to because Airflow like exposes that via their CLI and things like that. You can migrate between different versions, but you essentially give Airflow a database, even if it's like within like your MySQL cluster or your Postgres whatever. You may have other databases running there, but like you give it a database and it manages it for you. Like it migrates up and down as it needs to. It'll give you error messages if migrations fail, etc. And like that experience is what I was kind of thinking would be nice with cluster. Is like you give cluster a database and it manages it for you. um, Whether you use it for your other cluster storage in addition to mailbox storage is like your prerogative. But anyway, I can look
But anyway,
into
I think we can kind of have this discussion at a later point because first we make it work,
yeah,
second we make it efficient.
and then we make
That's
the
why
user experience very nice because the
I think that that has to be in between one and two.
yeah. But I think for now we can go with this just so that we have something to test with, and then I can start looking into as like as performance optimization and like optimizing around the MySQL case. I can start looking into like what it would take to write a stored procedure to get like this sort of information out, whether or not that would actually make sense and whatnot. But for now, this actually works reasonably well, aside from the fact that it requires two full network round trips, which obviously is not efficient. But um, so this is basically the SQL that does the inserting. And like I said, I've tested this against a MySQL database I was running just to see like if the query run behaves the way we expect it to. And it does. It actually works pretty nice. in terms of like, incrementing the message sequence number when we want it to. Um, so, um, so yeah. And then the other things that I have in here. So we have this like save message query, right? Which is the thing that actually gets the envelope. And this is the part that I have not integrated into sharding yet. But I think once I start integrating it into the sharding service, it'll probably become clear, like how I would instead use the entry instead of like the envelope. But anyways, when we save a message, we do the insert with all of these like things. So we actually run the query I showed you above. Um, Obviously, there will be a better error message in the future, maybe. Right now, I'm just dying. But um, the other thing I wanted to show you was
I
updating
mean,
a mess.
just one idea. Mm, entities are registered on the pod. Okay, so we have a registry of entities.
Correct.
In theory, the mailbox storage could fetch the entity type, get the protocol message, and actually validate the thing. Because there is an edge case here. The edge case is maybe even a security vulnerability. A malicious actor could send a validly looking envelope with a message that cannot be deserialized from the entity. So you would save an invalid message because there's no validation happening at
Hmm.
this point. We receive a serialized structure, we save the serialized structure. It would be very nice if this piece of the code does the decoding, checks that everything is right, then saves the encoded version that already received. There's no point like decoding and encoding again, but then it returns an entry of A rather than so an entry with the deserialized message in it.
So something
That
like
could be
receive message from wire uh, to deserialize
well
serialize.
check based on the entity type and the entity ID in the registry. Get the protocol.
Right. So deserialize and validate the message to obtain, or sorry, to. Uh, this would have to deserialize the message.
To deserialize the message, we need the schema for the message.
No, we don't. We need to. Sorry, this is to deserialize the envelope. Rather, we have the envelope, so deserialize is the wrong word. Use envelope to fetch the entity, uh, the addressed entity. Three would be validate.
You really need the entity type basically, not the instance, not the
Then in that
specific instance.
then in that case, we just need the entity manager.
Yeah.
We don't, because the entity manager maps to a type basically. So like, and then that entity manager actually manages all the types for an entity. So use the envelope to fetch the addressed to fetch the associated entity manager. Then that entity manager can be used to essentially validate the protocol, right? Deserialize the message, validate the protocol. Use the entity manager to deserialize the message and slash validate protocol. Because deserializing, decoding the message will essentially validate the protocol. Um, if successful, then persist the message to storage. Storage. Right? That's
And
actually a very,
return a typed entry, so an
yeah, that's
entry
actually,
which contains the real message.
return a typed uh, entry which contains the message. Yeah, this is actually a much better. This is a very very good point actually, and let me actually write that in here. Um, no, um,
Johannes in these cases would say, I'm known for good points.
A potential security vulnerability with the current implementation um, is if I just want to keep track of this. If a malicious actor writes a valid issues a request with a valid looking envelope, but um, like an invalid message or but with an invalid message. Um, in this case, we would end up persisting invalid data message data into the database. Yeah, very, very good point. Um, cool.
And also interface wise kind of make more sense because at this point then we have our entry, which is the thing that you basically ship to the entity.
Yeah.
It's no
Uh,
longer the entity that has to do the serialization. The entity receives basically as an internal queue
like it's
um,
actual
of
messages,
entries.
and actually that actually makes my life a lot easier because right now I have the entity manager typed with its message, but this actually doesn't really. I mean, it works, but it doesn't really work because if you look at the actual sharding service, which manages the entity managers, it's just typed with any because it can't know the type. But um,
Because in reality, that type should be an existential type, and they don't exist in TypeScript
right,
because it has an internal consistency. But you have
right.
like a protocol, then another interface that accepts the same message, but you don't know that type externally.
But the nice thing about this is like we can certainly have a map of entity managers of anything, right? But with your solution, when we actually do the storage persisting and blah blah blah, when we get the entry back, we already know that that entry has been validated with the entity manager. So when I actually implement in sharding, the thing that accepts the because I think the thing that I had already started working on, like this send to local entity manager function. This is the actual thing that you know the the wire protocol between pods is pluggable and it will continue to be. I think the default is the default of it being RPC is good, but it is technically pluggable, and I think it should continue to be. But the idea is that when you actually use that protocol to message between pods, when that message is received on the other end, you extract sharding from your environment and you run this send to local entity manager, and this is the thing that'll get the storage, do the validation of the message, do all of that sort of stuff. So now I can actually work on this in a much more like principled way, I think, because now when the entity manager actually gets the message, it doesn't have to do any work of like when it actually sends the message to its internal queue, it already knows it's a valid message. It's been persisted, it's a valid message, etc. Um, yeah,
And that probably like if that works after persistence, it gets a message entry, not an envelope.
right. Well, it depends on where we put that, right? Because like the send to local entity manager here is just going to get the envelope from the wire, and then it can do everything. Like it can try to find the entity manager for that envelope, use the entity manager to deserialize the message. If it's valid, put it in storage, and then write it to the mailbox queue. Um,
Oh, would the mailbox storage be actually part of the entity manager?
I think it makes more sense for the mailbox storage to be on the sharding service because I think it's like pod scope because in my mind, like the envelope hitting the pod, like the first thing we try to do is persist it, right? Then it gets forwarded onto the entity managers. So that
But
is
in
like
our case, to persist it, we need the entity manager.
it is a valid like question, right? Like, should the mailbox storage be associated with an entity manager, or should it just be associated with the sharding server? I think it's apples and orange. I mean,
Would
I
it
think it's
would it be wild to think that two entities might have different storage?
no, I don't think so, because right now, in the way we've designed our table, right? The way we designed the table, the primary key already basically separates entities by type. Like, they're totally distinct within the table. Even the message sequence number
In
is,
theory, I could have an entity type which is stored in a database and a different entity type which is stored in another one.
in theory, yeah. I'll try it out. I'll see how it feels, because that's kind of interesting. Um, I don't know how it would work from like a user perspective. Maybe like when you're actually constructing the entity, you provide you if you know you have the ability to provide it with mailbox storage as
A
well.
specific storage, or
Right.
it inherits from a generic, like DX. We can think about DX
Right after the
after, but
fact.
I do see cases where will actually make a lot of sense, because you maybe have something like, I don't know, a user storage where you store your users, then you have something else, and this actually even makes it for a nice point. If you really have a database that does ABC and you want to have some workflows running in that database, you could quite literally create an entity type, link it to your existing database, and that entity has access to that thing
Right.
automatically, even if maybe even transactionally, but
Yeah,
like
that's
transactions don't make quite a lot of sense here.
I'll try it out because I think that's it's definitely interesting. Um, the other thing I wanted to bring up, I know we only have a little bit more time, but the other thing I wanted to talk about was the way I've designed behavior. So I kind of went back to a Shardcake esque behavior design where a behavior we had talked about this, and I decided to design it exactly that way, which is the behavior of an entity is literally an effect that never ends. Um, so this could be, for example, a fiber that like never. I mean, it does end up getting forked into a daemon fiber behind the scenes, but the point here is that like
It's basically a while loop that fetches messages constantly.
forever, and you can fetch messages however you want. But an interesting thing for us to look at, and the type can be improved here. There's environment, and I was also thinking about Mattia and I had talked about how we could give behaviors access to a scope, like that closes at a particular point in time. Um, we can talk about that at a separate time. Like there's ideas I have around that, but what I do want to just quickly talk about is my
But it would probably be a never-ending scope, which
well, it
can
depends.
generate
Like
leaks.
it depends, right? Because a behavior is associated with a particular entity, right? That entity has an idle time, which in this design, like I kept the ability to provide because we had talked about this as well. I kept the ability to provide an entity with I don't remember where it is. In the options here, in the registration options, there's the ability to provide like a max idle time, which basically is the maximum duration of inactivity after which an entity will be interrupted. Right?
By the way, here there's a key difference between Shardcake and our implementation. This idle has to be not from the message received, but from the last message processed. Because otherwise, I might have an idle time of 15 seconds and a process that takes a minute, and I'll kill the process halfway.
Yeah, that's a good point. Without processing,
Yep,
having
having
without
processed the
having,
message.
so I have to
Either received or processed the message. Right?
received or processed a message. I do have to make that adjustment from a code perspective, but the idea here is that uh, hang on. Sharding. the idea here being that like if an entity is interrupted, if you have services scoped services that are registered to that behavior, like you still want maybe you want those to shut down like independently, like
Yeah,
some
but
like
that's just an effect that's scoped around the behavior.
yeah, I guess we can talk about it. I think that there may be merit, but anyways, I wanted to talk about in the time we have left about mailbox means, um, which is a type that I was working on. Where is yeah? So basically, I modeled mailbox as a queue with some additional methods on it. Um, I think the side of the mailbox that gets exposed to a behavior should be like a read-only mailbox, maybe, where we don't allow the because otherwise you could literally offer messages directly into the queue of the entity as you're processing a behavior. Maybe that's desirable, but probably not because then you bypass all of the like rest of
Yeah,
the
no,
things
that
that are
that
going
should
on.
not be done.
So
If you want that, you have to message yourself from the
exactly,
like
you still want to
get
go
a
through the
self
full
reference.
yeah, we still want to go through the full process of like serialize, deserialize, all of that sort of stuff because I think otherwise we talked about this, you run into weird bugs. But the mailbox itself, the side that the cluster sees, not the behavior sees. So from the user side, will get the read only side of this, where you have the take side, the DQ, as well as like all of these methods here, the acknowledge, succeed, fail, blah blah blah. But what's nice about having the right side exposed here is that once we're done, like we talked about, like once we're done and we grab the entity manager after having validated an envelope, you can then literally grab the mailbox from that entity uh, and offer directly to the associated entity, which is nice. So there's a bunch of helper methods on here that just basically allow you to either acknowledge or process a message. And then the implementation, there's going to be some errors here because I was working on this before we had our call. Let me, can I shut that off? Yeah. So the interesting one here, I think, is complete effect because everything else is based on this. Or no, complete because everything else is based on this. But essentially, when you want to acknowledge a message, it just grabs the mailbox storage and for that particular message writes an acknowledged state. I'll show you what this looks like in a second. And then when you want to complete a message, we get the actual result, which is the exit for having processed this message, and then we run the same storage.update message, but instead we run it with a message state.processed with that exit value. Um, and if we look at, I'm just going to turn my types back on. If we look at in the mailbox storage what that looks like, um, so here we get an address, we get a message, and we get the state of that message to write. Um, and what's nice about this message state type is that we can match on the state and either acknowledge or process the actual message. So acknowledging is easy. I'll show you what the query looks like in a second, but it's pretty straightforward. Processing is nice because the message itself has the serializable result uh, symbol, so we can directly serialize the exit and then complete that message. So we look at the actual queries. Acknowledging a message is just a void schema void request, which gets message identifiers. So the message identifiers are just like shard ID, entity type, entity ID, and message ID, and essentially just sets message acknowledged to 1 in the table for that message. And then completing a message gets this complete message type, which I'll show you because it's relevant. But if we look at the actual request, the exit at this point has been serialized. So down below, it's encoded, but not technically like serialized yet. Um, I'll show you what this looks like just a second. But basically, we ensure that acknowledged is set to 1, just in case there's like any weird state in the database. And the other thing to note here is we're always making sure that the message result hasn't been set already when we run these queries. Because if it has, then something weird has gone on, and we don't want to overwrite
Well,
previous.
also the message acknowledged should be 0.
True for this one, and good call. Equals 0. Oops.
I guess it's the same on the other.
No, right? Because we couldn't complete a message after it's already been acknowledged, right? Because if we do, for example, like the at most once processing, we're going to acknowledge the message right away. We're not necessarily going to complete it till later.
Yeah, that's true.
But the last thing I'll show you before we have to wrap up is this complete message schema. Why does this keep
Which, by the
happening?
way, we have to think about if we even want these utmost ones thing, because it makes more complex to model the caller of that. Because basically, when you call something, you send a message, you don't know if you're gonna get the response. Because if it's at most once, it acknowledges the entity dies, you're never gonna get a result. But how do you know?
Right.
Like, and the first thing is that you see the acknowledged, but you can't even error because, as you described, you can acknowledge and only after uh, process the final message. So I think it sort of um, creates problem in multiple places. I think we should force the user to deal with the fact that you have to do things idempotency, and that's like
Yeah, I mean,
that's
I think
that's probably the best.
I think it's going to be like one of those things that once we finish the initial like set of features here, we're going to like start testing it out just like, and we're going to realize very quickly, oh, this works, this doesn't, this works, this doesn't, etc. And I think that's probably going to be one of those things that is the first place where we'll run into like weird issues where a user might arrive in an inconsistent state and they won't know why.
Well, no, I simply mean the interface for like the ask. You have an actor, you ask a message, but if that message is then processed at most once, it might never be processed.
Right.
So what do I do otherwise? Wait for eternity, time out after 30 seconds. I don't think either of the choices make a lot of sense. If there is a reply, I should get the reply. Now,
We still haven't really discussed at length what the protocol piece is going to be like for a client, right? We
yeah,
haven't, and that's, I think that's going to be an interesting thing for us to talk about, like on a later design session, because basically we're ignoring that right now.
yeah.
But the last thing I'll leave you all with, because I think that I'm just like, I was very enamored by the APIs that Tim provides uh, in SQL, and all the other contributors to SQL as well. But the what's nice with this complete message type is we know that the database is going to give us something that's totally unknown, right? But we know that it's going to be we know that when we try to complete a message, we're getting it's going to be unknown, but we're serializing an exit previously, so we know we're getting an exit that's unknown. So if we wrap it with parse JSON, we actually go to update message and run the actual complete. The serialized side of this, like the encoded side, gives us back the JSON string because we know that when we run this complete we're going to be getting the exit here, and we can actually like have the exit come in here as well. Um, but anyways, I thought this was like I just really like the APIs around SQL. I think it's really flexible, and Schema obviously powers a lot of that too. So um, kudos to the rest of the team that are working on these APIs.
And I'm not sure if you've seen the latest thing the team is working on,
Yeah,
the
the model
model
features.
class variants. Yeah, that's
It's I actually tested out whether or not I could use it in cluster. I think that it might require a tiny bit more work for to be usable in cluster, but like it already looks so good from the perspective of like basically defining. For those of you who don't know or haven't seen it, it's basically a way to define a single model for your data that encodes like everything to do with like if you're persisting that information or not. It encodes like insert, update schemas, like basically all of that with like a single API, which is really really nice. Um, but yeah, I am kind of out of time for today.
yeah.
Um, but this was really good. I think that the comments that you made about the mailbox storage make a lot of sense, and I'll go in that direction, and we can probably talk about it the next time.
It good.
Very
That
good.
was a fun session.
Very fun. I like digging into code. I like design sessions too, but I also like digging into code and like thinking about it from a design perspective.
Maxwell likes to code.
I like to code.
Who would have thought, you know?
But anyways, thank you guys all for joining. Hope it was fun. And we'll see you all next week.
Thank you, folks.